So, who loves a good hackathon? Who got the idea for their company from a hackathon? We love hackathons too, but we actually think that hackathons are not just about creating some new tech widget. We actually think we can use the hackathon process to solve some of the big problems of our time, and we think that blockchain is a game changer. So we're really happy to have sponsored the hackathon along with the Central Bank of Papua New Guinea, because we've got some really tough problems in PNG that we think blockchain can solve, and the central bank thinks that blockchain can solve. And we came here a year ago and we sponsored the hackathon. We came up with 2 winners. We came up with a piece of game-changing tech that's now shortlisted at UN Women, and we're taking that device to UN Women next week. And we came to build on that. And over the weekend, we had 200 people, 30 teams from 40 countries working on some of the most amazing projects that potentially can be applied in PNG and other countries like that are tough markets, that we can solve some big problems. I totally agree with the previous speaker that emerging markets is where we'll see this technology leapfrog, and what we're interested in is making it leapfrog to solve some of the major social problems of our time: financial inclusion, climate change, women's and children's health. So I'm really proud to be here with the Assistant Governor of the Central Bank, Elizabeth Genia, who would like to say a few words about why the central bank is backing this initiative and why they think that blockchain is an important way to get financial inclusion in Papua New Guinea.
Thank you, Jane. Thank you. On behalf of the Governor of Bank of Papua New Guinea, Mr. Loy Bakani, it's been our pleasure to sponsor the 2018 hackathon. Now, many of you will be asking, why is the Bank of Papua New Guinea getting involved? Papua New Guinea, a country way near Australia, up north of Australia. Why are we involved? It's simple. The Bank of Papua New Guinea has an objective to achieve financial inclusion for all its citizens. And for Bank of Papua New Guinea, this starts with the provision of a unique identity of all our citizens. And for many, this will be the first. In Papua New Guinea, it's especially important for women. As an advocate for women in blockchain, I want to personally see more women engaged in the fintech sector. Thank you.
Okay. So it's great to be backed by a central bank. It's great to be backed by a woman leader in a central bank. This is going against the tide in the blockchain community. Watch out, it's not just colour coming, we're coming. Okay, so now we had some fantastic pitches last night. We had 30. We didn't know how to choose winners. Many of them were really winners and we were interested in working with them, but we did have 2 winners and we're really happy to have them come and show you some of the exciting projects that they're working on. So the first team was Ground Blocks. So please come up and present your tech. You can go back here.
Good afternoon, everyone. We're the Ground Block, team of 6, concerned with the land ownership registration in developing countries. Currently, land registration in Papua New Guinea happens by having 2 representatives of tribes walking around the land with the government official and declaring which land belongs to who. Everything is recorded on paper. Usually, the separation is very vague, using a tree or a river. So obviously there's a lot of problems that comes with it. And Papua New Guinea is not the only country that comes with these issues. In Africa, for example, only 30% of the land is mapped, making it hard to collect taxes, define the ownership of the land during the conflict, mitigate land disputes. So we came up, we identified 3 main improvement points. First of all, defining the location. Obviously, because the separation point is usually a tree or a river, it's usually really hard to say which land belongs to who. The second, authorization process. Everything is recorded on paper, and then the paperwork is sent to the government entities in the capital. During that process, the paper can be lost or damaged. And financial inclusion. If the countries like Papua New Guinea would have a verified register of the land ownership, that would mean the villages and tribes would be able to use that asset to take bank loans, improve their living conditions. So our solution is very simple. The tribes are still walking around the land and declaring which land belongs to who, but they're using a GPS devices to do that. The coordinates are recorded in the blockchain, where the data is authenticated and accessible, public accessible. More about that, I'll give about the implementation. Martin's gonna talk about it.
Thank you, Gabby. So I just want to talk about how we implement such a solution, how we implement blockchain technology in a country where we do not have reliable electricity. In many remote areas, there isn't reliable telecoms or infrastructure, especially in more remote areas. There will be no telecoms signal, no 2G whatsoever. So firstly, to talk about cost and electricity, we've designed our devices to be as cheap as possible, and by removing the concept of proof of work from our blockchain and using other security methods, we've been able to really reduce the power consumption down to normally below 0.2 watts and keep the cost of the devices we're using down to $70. And again, we should be able to reduce that with economies of scale. By using GPS devices, we can make these systems much more accurate. And because it's such low cost, we can use renewable energy sources costing between $2 and $15 to power these devices without an electricity grid. So we've designed an interface here that government officials and approved financial institutions will be able to use to see who owns which area of land, when that was approved, and who it was verified by. This can really help with financial inclusion because as approved financial institutions can see this data, this gives communities a financial asset which they can borrow against if they so choose to. So one of the key challenges we faced was that if you do not have even phone signal in certain areas, how do you communicate with the entire network? So we have designed a mesh network where each device acts as a node in the network, and when one node wants to submit a blockchain, it will pass the data to the nearest nodes, and that will then be propagated throughout the network. This is robust because if one node goes down, it will simply find a different route through the network. So to summarize, we have designed our devices to be very low power to overcome the issues of lack of electricity in many areas. We've overcome language barriers by using devices which are very simple to use and very pictorial and have largely just simply two buttons without even needing a screen on the GPS devices. Using the mesh network enables us to overcome the lack of telecoms infrastructure or internet in large areas of the country. Using GPS makes it accurate, and we're using biometric identification to prove who verified the transaction. So it is proven that the two tribes who are bordering the land border that's being registered and the government official have approved it, and we have a very low price which can be reduced if we're buying in quantity. Thank you. I'd like to finish up by thanking the sponsors. It was a fantastic hackathon. There was a buzz of energy around the place for the entire weekend, and that wouldn't have been possible without the sponsors and the Central Bank of Papua New Guinea. Yeah, it's a good question. So he was just asking what the distance is between nodes in the mesh network. So generally we should be able to get a distance of about 20 miles, but that will vary depending on the geography of the area. So there are many areas of Papua New Guinea which are mountainous. That distance would obviously come down in those situations. But for most areas, particularly in rural areas, you can get fairly large distances if it's flat because trees don't affect the signal as much as a built-up area like London would. That's good.
Any other questions?
Who's going to prove the ownership?
Sure. So whenever you have two tribes with a land border between them, you'll have a government official go to negotiate that boundary, and then before the block is submitted to the blockchain, it will have been verified by both tribes and by the government official using biometric identification. And then because the block has been signed using the private keys of those 3 different organizations, 3 different groups, this is proven to the network that it has been correctly authorized.
Okay, thanks. So a big round of applause for that great project. Okay, and we'll invite the team. Trawl, come on up and present what is an unexpectedly interesting project.
Team Thor. For farmers all around the world, being able to anticipate an impending drought, heavy rain or frost, and being able to act in advance is the difference between being able to feed their families and not having a meal at all. It's the difference between being able to send their kids to school and not knowing, not having enough to pay for the basics. We know that weather is of great importance on a global scale, but on a local level, it's often forgotten. We introduce you to Thor, a decentralized weather data system that will democratize weather information on a global scale and provide better access to better weather forecasting. In Papua New Guinea, 88% of the population live in rural and remote areas. 75% of the population rely on agricultural upkeep for their livelihood. Improved weather forecasting will lead to better harvests, which will provide more reliable sources for food security and income. Research has proven that with improved local weather forecasting, we can predict outbreaks of pneumonia, of tuberculosis, and one of the biggest killers in Papua New Guinea, malaria, enabling authorities to act faster. 30% of the country's GDP comes from agriculture. Improved weather forecasting will help exports, will improve decision-making around transportation, and will enable governments to help the country prepare for climate disaster, natural disasters. Improved forecasts comes from more data points. This is how many weather stations are in the UK. This is actually a zoomed-in picture of northern England. This is how many weather stations are located on the mainland of Papua New Guinea. Farmers are effectively guessing the weather. What we want to achieve is this. The way we want to do that is to install 3D printed weather stations, which will cost roughly $400 a piece, a pop, rather than $10,000 to $15,000 for a traditional weather station. And then we plan to put the data that comes from these weather stations onto the blockchain. So instead of individual Met officers storing their own version of the truth, the blockchain will provide a global infrastructure for open weather for open weather data for anyone to access. So the way this will work, the weather stations will submit the weather data to the blockchain via a text message, SMS. The weather forecasters will then take this data, read it, and write their forecasts and put it back onto the blockchain. And radio broadcasters and citizens will be able to request the weather forecast via text, or where accessible with web interface or smartphone. And the next layer of this, and potentially the greatest impact, is when people will actually have weather advice in these specific weather conditions. So the forecast will actually come with advice on how to act. So finally, with more reliable weather forecasting, farmers will know when to plant their seeds. Governments can predict malaria outbreaks. Commerce can make better business decisions, and people will be better prepared in the case of a natural disaster. Weather does not stop at borders. More access to weather data means a more informed global community and the ability to lift the poorest in the world out of extreme poverty. None of this, though, would have happened without this amazing team that have come up with this idea, and of course the London Blockchain Hackathon, run by Antonio, who's the founder of the London Blockchain Connector, and of course the sponsors. Thank you very much.
So who would have thought? What a great project. It was totally unexpected, but we all thought that it was awesome and really could make a big difference. So anyone got questions for the team?
What are the next steps to roll this project out?
I believe the first step is to make it possible to obviously write weather data to a blockchain that can be shared between Met offices and universities and researchers worldwide. So I think the first step is actually getting the data, they're already being collected and written everywhere, onto that blockchain. And when we have that, we take to install 3D printed weather stations in remote areas. These 3D printed weather stations are being installed in places like Zambia currently, and they're working really well, and they're providing Zambians with better weather forecasting. So seeing something similar is a massive data gap in the developing world when it comes to weather. So majority of the developing world only have guessing weather forecast, and it's actually the biggest areas where people are farming, and it's quite sad that we have the best weather forecasting, and I don't do much farming, if I'm honest. And so, it really matters to me, and I think it's very important that we bring this to people who really need it.
Okay, thanks. Another question? Yes?
My question is just about how you get the data back from the weather stations. You said by SMS, but is there
SMS.
sufficient cell coverage to be able to do that in remote areas? And how expensive is it?
So there is obviously a cost per text message, so there needs funding to be able to fund that. However, you can go down 2 different routes. Do you want to go down the route that effectively the weather station owns its own data? And when you want to access that data as a researcher, do you pay for it? And if you look at it from that perspective, then we can charge for that data. The weather station can fund itself with the text messages it needs to send back.
Big round of applause for this team. Thank you. Okay, so thank you. And just to reiterate that it was one of the most lively hackathons with a great buzz around. Everyone was working really hard. 200 of the smartest people from all around the world trying to fix some big problems. And we think that this is a way of actually bringing the tech community together with some of the big problems of the world to help us solve them. So it was fantastic. So thank you, FinTech Week. Thank you, London blockchain community from 40 countries. It was a great experience, and I encourage you all to go to the next one and just participate. Thank you.